Awesome. Hello, everyone. Happy Wednesday. Good morning, good evening, good afternoon, wherever you may be located. Go ahead and get the GMs. Feel free in the meantime to just toss where you're from in the chat. I've probably done this in the past, but still love just seeing kind of where everyone on the Zooms are located and just see just how global the entire audience is. We're going to start here in just a few moments. I want to just give a few updates. So moving forward, if you have any questions about your project or anything like that regarding the hackathon, please do reach out to myself or toss my kind of contacts here into chat. Reach out to me on email or Discord. I know we're wrapping up the hackathon here shortly, but if you do have any questions or anything like that, don't hesitate to reach out to myself, and I'll be sure to provide you with help or kind of point you in the right direction. But yes, we'll go ahead and get started. If you do have any questions here throughout the presentation, please do throw them into chat. And I'll be throwing some important links there here in just a few moments. But without further ado, kind of official introduction here. Welcome everyone to the final StarkNet workshop. We have the Aave Ethereum StarkNet Bridge here being presented by Massil from Nethermind. Where did I go? There we go. Massil, thank you so much for joining us, and feel free to take it away. Welcome to share your screen or kind of present in whichever way you prefer.
Okay, nice. Hello, everyone. So yeah, thanks for the intro. So indeed, today I'll present a bit the bridge between Ethereum and StarkNet for Aave. So this project has been coded from March to June, I would say. Then we run like several audit processes, and now we are good to deploy. It should be deployed really soon, and should be announced like in the upcoming days on Aave Governance Forum. So today I explained to you, I mean, the session will be divided in two parts, I would say. The first is like a usual presentation of the project. So a few slides explaining like what we are trying to achieve, how we have implemented this, and also like interesting design choices. And the second part is more technical, and it might be interesting for people who are building projects between Ethereum and StarkNet, because I'll deep dive into the cancellation feature, which is actually one of the key features of message communication between the two networks. And yeah, well, I'll explain to you how it works more precisely. And yeah, it's a good occasion to deep dive into that part of the code. So yeah, we'll be divided in two parts. I'm supposed to share my screen now. So in a nutshell, yeah, a few forward first. This project has been like the first step of Aave to StarkNet. It has been discussed first in December of last year. And as a first step, Aave wanted to create a bridge to bridge their aTokens. I'll explain like in a few minutes what aToken is to StarkNet. So that's the first part. But yeah, first let's explain what Aave is. So probably most of you are aware of that, but Aave is a DeFi protocol, one of the most famous one, where user can deposit some token, earn tokens as yield, and borrow assets given depending on the amount they have deposited. I haven't precised it here, but Aave is deployed on several EVM compatible chains, namely Ethereum, Optimism, Polygon, Arbitrum, Avalanche, and now they wanted to enter the StarkNet world. And in practice, in Aave protocol, when a user deposits some token of type A, let's say DAI, for instance, he will first earn yield in the form of token A, named aDAI. I'll explain like in the next slide what aToken is. Earn reward tokens in the form of staked Aave, and also he will be able to borrow a given amount of token of type B. let's say that you want to like borrow, like I would say, a governance token of Uniswap, for instance. And Aave also supports two kind of loans. So collateralized ones, which are the usual one. You deposit some token, you can borrow some other token, but less than what you have deposited. And also uncollateralized loans called flash loans. And they have been like, yeah, famous in the last few months, especially for their for the hacks they made possible. And now, okay, Aave to StarkNet. So the project has been divided in two phases. So the first is build a bridge between Ethereum and StarkNet. And the phase 2 is rewrite Aave protocol into Cairo. So the first one, we have finished it for a while. We run like the audit processes. And by the way, the audit reports are available in the repo. And it's supposed to be deployed really soon, like in the upcoming days. At the beginning, I thought it would be deployed yesterday or today, so that we could try it during the call, but yeah, it's not, it has been delayed a bit. But yeah, this is the first phase. And the second phase is really writing the full protocol into Cairo. We have already started to do that task if you want to have a look at the repo. But yeah, today we'll focus on the first one. So what is a aToken? aToken is like a nickname for Aave token. And it's this kind of token is basically at the core of the concept of pools, like generally speaking in Solidity and Ethereum. Yeah, let's say in smart contract even, because when you deposit some token to a pool, the pool will send you some other token as a proof of deposit. And this is what a token is. So let's say that you have 100 DAI, you deposit those DAI into Aave protocol, then the protocol will mint you 100 DAI, which are basically a receipt saying that indeed you have deposited 100 DAI into the protocol. And the thing is, since those protocol, they make you earn yield, the amount of tokens you have will increase over time. And it will increase at the rate of what's called the liquidity index. So this name is not standard in the community. Liquidity index is like Aave wording to say rate, for instance. And so the liquidity index with Aave, your number of aTokens will grow in balance, and I'm insisting on that, while holding them, which means that if you once deposit 100 DAI, you will receive 100 DAI, and if you wait for a while, you will receive 5 additional DAI, so you will get 105 DAI, and you can withdraw those 105 DAI in 105 DAI. So at the end, you earned 5 DAI globally. And yeah, this is really, I mean, the fact that they grow in balance is really specific to Aave, and I'll explain later that it's not always like that. And also with Aave, you have like a rewards index, basically like the index at which you will receive reward tokens, but we won't stress on that today. And like the key difficulty for this bridge was that we want to have so just on the image, like L1 is Ethereum, L2 is StarkNet. You don't need to like understand like everything, but it's just like to highlight a bit like the important part. So yeah, I was saying that the critical part is that you want to have the same liquidity index on both networks, which means that you want like this value to be the same, but this value is dynamic on Ethereum. So to have the same, you would need to send a lot of messages from L1 to L2. And this is not really, I mean, this would be like a gas consuming approach. So the approach to have those aTokens on L2 has been a bit different. because instead of having aTokens on L2, we represent those aTokens into what we call static aToken. But if some people are familiar with like other token standards, those static aTokens are basically C tokens. So I'm explaining here what's the difference. So on StarkNet, the aTokens will be represented by static aTokens. And aTokens, they grow in balance. So as I said, when you have like 100 aDAI and you wait for some time, you will receive 105 aDAI. But the static aTokens, they don't grow in balance, but grow in value. And the thing you should, the example you should have in mind is, for instance, shares, like shares of a startup, let's say. At the beginning, you hold 1%. And if like if you don't like increase the number of shares, those you will still get like 1% of the whole company. But over time, the company's value should increase. So your 1% will have more value. So in a way, static aTokens and also C tokens, they represent shares, so they can grow in value, while the aTokens, they represent like basically the equivalent number, so they grow in balance. So for people who are familiar with Compound, for instance, so Compound, they use the C token, and they have created like the C token standard. And with Compound, when you deposit 100 DAI, you don't receive 100 C DAI, but you receive, for instance, 22 C DAI, and you will hold these 22 C DAI over time, and the number of C DAI will remain the same, but the value of one C DAI will increase over time. And this trick actually enabled us to represent static aTokens on L2 by aTokens that are stored on L1, that are like stored in a bridge contract. And basically, you are sure that the static aToken you have on L2, they are backed by aTokens that are on L1. You know that those aTokens, they grow in balance, so their value increase overall. So the representation on L2 will also, their value will also increase. So it's a bit tricky to explain it like that, but when you think about it, basically on L1 you have something that increase in balance, and like it's represented by something on L2, and it won't increase in balance, but in value. So yeah, I hope it was a bit clear, but don't hesitate to ask a question if it's not. And also, yeah, so those static aTokens, they're useful for cross-chain liquidity because they enable you to have to represent the same value amount without active communication between the chains. This active communications is basically syncing the liquidity index. And also, like, holders of this token will be passively accumulating yield from Aave on Ethereum, which means that if you hold a static aToken on L2 and you wait for some time, you know that the number of aToken you can withdraw on Ethereum will increase over time. And yeah, the indices. So yeah, this part longer. I wanted to explain the reward index in that part, but it's no longer relevant. So yeah, now let's go back to the bridge I showed you. So here the process is like you're on L1, for instance. You want to deposit some tokens to the token bridge on L1. So what happens here? Your token, so basically aToken, they will be stored by L1 token bridge. Then the L1 token bridge will send a message to L2 saying, okay, I know that user A has deposited 100 aDAI, for instance. So when the L2 message received this message, so it knows, the L2 part knows that the message comes from L1 bridge. The L1 L2 part, sorry, will mint those static aTokens. So basically those tokens will be new, like minted by the bridge. And then you will send those tokens to the StarkNet user, let's say B, that you have, which is the recipient of the deposit. So the first flow is from L1 to L2. So you deposit some token on the L1 counterpart of the bridge. The L2 counterpart of the bridge will mint those tokens, and the StarkNet recipient will receive those tokens. Now, let's say that you want to withdraw token from L2 to L1. So there's the StarkNet user will actually send tokens to the bridge. No, sorry, just made a small mistake. So it's also initiated from L1. So you're calling the function to withdraw, and then the token bridge will transfer like static aToken from the user to the bridge. Since the L2 bridge knows that the L1 bridge want to withdraw some token, the bridge will burn those tokens. So the L2 bridge is able to mint and burn the static aTokens, and it will send a message to L1. And when the message is received, the L1 user can finally get back the number of aTokens, which should have increased over time. So yeah, this is how it works overall. So I haven't explained like the reward Aave and also like the governance part, because yeah, it's not part of the today's talk. But yeah, just wanted to explain overall how the L1 and L2 part works. Basically, send messages from L1 to L2, and the L2 part will mint and burn tokens to the StarkNet users. So now, so that was, I would say, the first part of the talk, basically explaining how the bridge works overall. So now I wanted to make the session a bit more interactive. So I know that you have already had several workshops about StarkNet, and I wanted to deep dive a bit into the code, and especially like on the cancellation feature. So the cancellation feature is like one of the features implemented by StarkNet contract on Ethereum. And it's like basically, I mean, this contract is like the core contract that handles messages between L1 and L2. And yeah, wanted to highlight a bit what's inside that part, because the first guess we have is usually wrong. So yeah, basically today I'll explain like how the StarkNet messaging contract provide functions to cancel messages that has been sent from L1 to L2. So first, I mean, is someone knowledgeable about that? So can someone like explain how it works? Okay. Actually, I don't know whether the session was supposed to be interactive or not. So, so yeah, let's say that you don't. Yeah, sorry.
No, yes. So anyone in the audience, feel free to raise your hand, type it in chat. We love interactivity. So yes, if anyone has an answer, feel free to answer whichever way you prefer.
Okay, I don't see messages because I'm sharing. Is there any message?
Yes, we have someone who asked a question. Can you see it now?
Yeah, what's the question?
Yes, is it true to say that static aToken is not pegged to Aave, while the aToken like DAI is pegged to dollar?
Yeah. Good question indeed. That's a good moment to ask question, because the second part will be like more into the code. So they are not pegged. Basically, I'll keep with the DAI example. Like the DAI and a DAI, they have like they correspond to the same value, which means that if you have 100 DAI, you deposit to Aave protocol, you will receive 100 a DAI, And conversely, if you have like 110 ADAI, you can withdraw and get 110 DAI. So this is the same, but static aToken is different. Basically, static aToken is Aave wording to say C token. And C token, how it works, you deposit 100 DAI. You don't receive 100 C DAI, but as I said like a few minutes ago, let's say 22. So you will receive 22 C DAI, but the value of C DAI will increase over time. And by the way, maybe it's not clear. Why does it increase? Because the C DAI token, so it represents a share of like the whole fees, I mean, all the fees earned by the protocol. But since the protocol will earn an increasing amount of fees over time, you basically own a share, but the share correspond to, but the total will be an increasing amount. So your share will also increase into value. So as I said, you have like 100 DAI, you get 100 C DAI, but these, 22 C DAI, but these 22 C DAI, their value will increase over time, and then you can withdraw like a higher number of DAI at the end. So in one sentence, static aToken is not pegged to aToken, but you can have like you can basically have a function to convert from one to the other, and conversely. aToken is not pegged by aToken like DAI pegged to $. Yep. So that was good. Okay, so I don't see messages about the cancellation mechanism, so I'll explain how it works. So getting back to showing my screen again. So yeah, the first, usually when we think about it, when we think about like cross networks communication, we think that it works like that, and like most of us think that it works like that. So basically, on the left you have Ethereum, on the right you have StarkNet. In green you have like a major contract called StarkNet contract, but we'll look at it like in a few minutes. And what happens is you send a message from L1. So there is a function to do that called send messages from to L2. Sorry, I'll show it to you later on. So you send a message from L1 to L2. This message will be somehow stored into a StarkNet contract. Then, like a few minutes after, it will be consumed, and then it's executed on L2. So in our case, for instance, as I explained, when you deposit some aTokens on Ethereum, so you send a message saying that user A has deposited 100 ADAI to the contract. So this message, it will be stored to StarkNet contract. Then let's say that the message is consumed. We don't know how, but let's say that it works like that. And once the message is consumed, the L2 bridge will mint you the static aToken on L2. So this is like the how we feel that it works, but it's not working like that. It's like way more complex, and it actually involves the prover, the verifier. So you really need to understand like StarkNet architecture to understand fully how it works. So this is like the naive understanding, but it's not the correct one. So yeah, what happens when you deposit to L1 bridge? So high-level explanation: you send X aToken to L1 bridge. A message is sent to StarkNet contract on Ethereum. Yeah, we'll look at it later. And then the equivalent of those tokens will be minted by L2 bridge to an L2 recipient. So this is what I explained. But yeah, this is overall how it works. So this is not wrong, but to really understand like message cancellation, we need to better understand what consumption of messages mean. So be prepared. It's a bit, more complicated, but in practice, it works like that. So the beginning is the same. So you send a message from L1 to L2. Then this message will be stored. So it will be stored in StarkNet contract in a mapping, like, yeah. But by the way, StarkNet contract is written in StarkDT, so it's really well written, so it's easy to understand. So yeah, your message is stored in a mapping of the contract, but it's not removed yet, so it's not consumed. It's still in the contract, and afterwards the message is executed on L2. So the L2 bridge will mint you static aToken on L2. Then if you remind like the way StarkNet works, when something happened on StarkNet, yeah, two things happen later on. So you need to prove that the transaction is valid. So this proof will be created by the prover. The prover is like enough chain service proving that transactions are valid. And this proof will be sent to the verifier on L1, and the verifier will check that it's valid and then store this proof to in what we call the fact registry. So if this is the first time, sorry, if this is the first time you hear about it, it's like probably really confusing. If it's not, you remind like how it works. But yeah, overall, 4 is like the execution is proved by the prover. 5 is the proof is checked and stored somewhere on Ethereum. And finally, at step 6, the message will be consumed. And by consumed, I mean removed from the mapping of StarkNet contract, sorry. So it's like way more complicated than what people usually think, because you first execute the message on L2, and then you do some operation. I mean, you have to wait some steps, and the message will be removed, cleared later on. So this is, yeah, I explain like later what how it can be a problem. But yeah, basically this is how it works. So I explained the different step, like in using bullet points. It will be a bit hard, but yeah, basically here the goal is really to look at the code. So I'll open the screen. So first step, so you send a message to the contract StarkNet by calling deposit on L1 bridge. So what does it mean? So this is the code. By the way, I should, yeah, let me do that now, because otherwise I will forget. Yeah, I'll send the link of the presentation later on. So yeah, sorry. So basically, you send a message to StarkNet contract by calling deposit function of L1 bridge. So let's go to the code. So this is the repo we have called Aave StarkNet Bridge. And on Ethereum part, we only have one contract, so the L1 bridge, and it has one function called deposit. So as expected, this is the function to deposit some token to the bridge. And what happens here? Basically, you do some operation. It's not like the most important. But here you send a deposit message, and what does this function do? It will prepare a message to send to L2, and then call the function send message to L2. So this is like yeah, this is like the important part, because this is what we're doing here. We're sending a message to StarkNet by calling deposit function of L1 bridge. Then StarkNet contracts will record this message. So every time you call this function, send message to L2, it will store a message on StarkNet contract. So yeah, we are here. So this is Etherscan, and we have like the contract that is deployed. Okay, I'm a bit lost. Where are we? Okay, here. So yeah, this is the function we have showed you. Send message to L2. So what are we doing here? We are checking some value, computing a hash given the inputs, and then storing a hash into into this mapping. So this is what I described at the beginning. And in this diagram, because here the message is not consumed as a step, it's just stored. And this is like really important. So yeah, where are we? So yeah, this step we have done it. So StarkNet contract records L1 to L2 messages. Yeah, see here. Then message is consumed on L2, and this function is executed on L2. What is this function? It's that one. So if you are familiar with Cairo code, you know that when you send a message from L1 to L2, you need to, the function that will receive the function first needs, that will receive the message, sorry, first need to get this decorator, L1 handler, and this will handle the deposit message, which means that it will receive the message saying that you have deposited some tokens to L1 bridge. So the goal of this function is to mint static aToken to like the user to L2. So where are we doing that? We are doing this here. I guess, yeah, here we're indeed minting like static aToken to the L2 recipient. Okay, so this is this is the step 3 here. So the message is executed on L2. Then 4 and 5. 4 first, we don't have the code because the prover is currently closed source. 5, it's not like the time to look at it, but basically, if you remind like how StarkNet architecture works, you can find the corresponding code. And so where are we? StarkNet prover creates a proof that L2 function has been executed. So that the function, handle deposit here has been executed. Then next step, StarkNet verifier. So it's a bit misleading because verifier is on Ethereum. Let's say Ethereum verifier. No, verifier is fine. Verifier check that the proof is valid. Okay. Then the proof is stored in the fact registry contract. So this is really important. And then StarkNet contract checked whether the proof is stored. And finally, the message is removed from L1 to L2 messages. And let's look at it. So yeah, this function, so it's still the same contract, so StarkNet contract. So it contains a crazy amount of interesting information. So it has especially a function called update state, which is called by an operator, so probably like controlled by StarkWare. So this function update state, what will it do? It's a bit tricky. Where are we? Okay, we are here. So yeah, it will require basically, it will check here that the SharpRight. Yeah, okay. So here it will first check that the proof you're looking at is indeed in like the fact registry. If it's not, it will revert. Then it will process, first L2 to L1 messages. It's not what we're looking at. We are actually here, process messages, and actually this function, what does it do? It's not here, it's in output, sorry. Here. It's finally here, so it's really, really hidden, but in the function process messages, if the fact belongs to the fact registry, so sorry, if the proof belongs to the fact registry, you would finally clear the message that has been stored at the beginning. So in a nutshell, what have we shown here? We have shown that we have showed that the message is only cleared at this step. So this is really, really important because, and this is why the cancellation mechanism has been introduced, because here, so yeah, here, to be really honest, I didn't have the time to write like a new diagram to explain that, but I can explain here. I can explain it here. Yeah. By the way, before I'll just look at questions. The security concern will take care if copyright will be in L1, proof in L2. So yeah, not sure to. I mean, I think you felt that something is tricky here, Efrain, in your message. But yeah, it's not correctly written. But basically, yeah, does someone know what can what can happen with this process, with the fact that you store, that you clear the message at the really end? What could happen, for instance? So yeah, if you have like any hint, please write a message in the chat. Okay, people are a bit shy. But yeah, basically, I'll explain this in this diagram. So yeah, it's a bit tricky, but let's think about what can happen. Let's say that you have like tokens on L1 and you want to deposit them on L2. You send those tokens into the L1 bridge. Okay, then the message will be stored in StarkNet contract. This is fine, but then let's say that you never receive your that the L2 part never mints you the static aToken. It can happen for two reasons. Let's say that you have like a bug in your code, so basically the transaction is never happens, and it will be the transaction fails and it will never mint you the static aToken. This is the first part. But let's say also that StarkNet is down for some reason. We never know. And let's say that StarkNet is down for a few days and you don't receive your static aToken on L2. So then you're wondering, okay, so sent like tokens from L1 to L2, but I received nothing on L2. So I want to get back my token. And this is why the message cancellation is useful, because as long as like the message is stored in the StarkNet contract, you can ask for message cancellation. Because what does it mean? Because as long as the message is stored on StarkNet contract, it means that the transaction on L2 has not been proved. So it can happen like if StarkNet is down, and it's important to have this in that way, because yeah, losing a bit flow. Yeah, okay, sorry. It's important to do it that way, because if StarkNet is down for a while and you want to cancel the message you have sent, as long as the message is stored on StarkNet contract, you can retrieve your funds. So you can create a function saying, okay, the message is still here. I no longer want to have my tokens on L2. I want to cancel this. So you can create a function sending asking for the availability of the message to StarkNet contract, and you could get back the token you have deposited on the L1 bridge. So this is the first part. And also, here, ideally, like how it would be good if like someone could like try to think about another problem. Thanks. Okay. Notification is ongoing, cancellation is requested. Okay, very good. Very good. Very good question, Said. So actually, yeah, I want to look at the code for that because, yeah, it was really, I mean, basically I was expecting two questions from you. This is like the first one, because when I talk about like message cancellation, yeah, by the way, I think I'm no longer sharing my screen. So yeah, basically when I talk about message cancellation, this corresponds to two functions on StarkNet contract. The first one called start message cancellation, and the second one means is called cancel the message, so actually cancel. And so start message cancellation, you can call it as long as the message is in the contract, because it's basically the condition is here. You are like retrieving the message and checking that the value corresponding to this message is greater than 0. And then, so it's basically a function to say, okay, I think that something is weird. I want to start the cancellation mechanism. So this will record the timestamp here in this mapping. And then you have to wait like for some time. In practice, you have to wait 5 days. So yeah, so you could think about like 5 StarkNet being like down 5 days in a row. This is where like this process would be useful, because here 5 days later you can actually cancel the message. So it will first check that the message hasn't been cleared yet. So it means that the function hasn't been executed on L2. So this is the first condition. And the second condition is checking that you have called like the start cancellation mechanism 5 days ago. So those are the two conditions. And if those conditions are met, you can actually cancel the message. And this is honestly, this is really really tricky, but this is like nice when you really understand it, because it means that let's say that you are on Monday, you deposit some token to the bridge, then 1 day later you can see that you don't have like your tokens yet on L2, so something is weird. Okay, what you can do is call this function. Then if the message is processed meanwhile, it will be cleared from the contract, so you could no longer call that one because of this condition. But if it's not the case, so if like StarkNet is down like for more than 5 days in a row, it means that you can call this function because the message is still here, hasn't been cleared, and and you have waited like enough time to be able actually to cancel the message. And this is how you can retrieve your funds. So in practice, like when something bad happens on StarkNet, or when the code you have written on L2 is failing, you would need to wait 5 days to be able to cancel the message. Like this is like, I would say, the important take-home message. Like to cancel a message, you have StarkNet to be down for 5 days, or like you have to wait 5 days before it's clear that the transaction hasn't been proved and something bad, something wrong happened on L2. So yeah, this is very, very good question. So yeah, looking at, okay, I could look at the chat here. Is it possible to share a presentation? Of course. Okay, great. And also, just to let you know, this feature, we deep dived on it because one of the audit companies asked us about this flow, because in practice, the weird thing is, if you think about it, and this is why it's so tricky. Let's say that you have like tokens on L1. Sorry, step 1, so you send token to the bridge. Step 2, the message is stored. Step 3, you have like your static aToken on L2. So at this step, you can start the cancellation mechanism. And it's a bit weird because, because you have received your token on L2, but still you can bet that StarkNet will be down for 5 days. So start the cancellation mechanism. So at the same time, you hold like some tokens on L2, but still you're able to start this mechanism. And if the process works correctly, the message will be cleared meanwhile, and you won't be able to actually cancel the message. But still, it's not trivial that you can at the same time hold your tokens on L2, which means that the flow worked, and also start like the cancellation mechanism because you feel that something is not working. So yeah, this part is a bit tricky to understand. This is why I'll send you the presentation with the links of the code. But yeah, this is like, I feel that it was interesting to deep dive on that, especially because you have already had like a workshop on L1 to L2 messaging. So yeah, this is where we finish like today's presentation. Yeah, questions, but yeah, we already answered some questions.
Great. Yes. Any final questions from the audience here? Feel free to raise your hand, of course, or ask them in chat. But again, Massil, thank you for the amazing presentation today. We'll wrap up if there are no questions here. And just as a reminder to everyone, this event was recorded, will be posted online by tomorrow morning. We'll be sure to include the presentation and all the important links that you need to go back and rewatch it and kind of learn the things again. So thank you for sharing that.
Yeah, by the way, feel free to share it, like, I mean, in your internal documentation or like, because yeah, it's important. I've added the links. Probably I'll add like another diagram or a better experimentation about the end, because it's not so well documented. And honestly, to really understand, I had to ask questions on like Telegram groups, like really chase like StarkWare people to understand how it works. And by the way, it's interesting because they said that this flow will probably change after Cairo 1.0. Yeah, especially because from Cairo 1.0, you could prove failing transaction on L2, and this changed a bit the flow. But still, it's interesting to look at it for people who want to deep dive a bit on that part.
Great. Yes, thank you. And just a quick reminder to everyone, we are coming up to the final weekend of the StarkNet Hackathon. So submission dates is the 30th of October at midnight, your local time. If you do have any questions, concerns, or anything about your project or the hackathon in general, please do not hesitate to reach out to myself there moving forward. And again, looks like we have no final questions. So once again, Massil, thank you. Amazing presentation, and thank you to everyone for showing out. And looking forward to seeing what you build here over the next couple of days.
Okay, all good. Thanks for the invite. Yeah, it was a bit tricky. It's always tricky to explain some code and deep dive because it's like boring and yeah, really complicated at the same time. But yeah, I invite everyone to have a look at the presentation, look at the code, take your time to understand. Feel free to reach out on Telegram or Twitter if in case of you have like any question about that. This is the same handle for both. And yeah, good luck for the hackathon.
Awesome. Thank you. You did a phenomenal job. And to everyone, have an amazing rest of your day, evening, afternoon, wherever you may be located. Thank you.
Thanks. Bye-bye.